Open channel flow, a branch of hydraulics and fluid mechanics, is a type of liquid flow within a conduit with a free surface, known as a channel. The other type of flow within a conduit is pipe flow. These two types of flow are similar in many ways, but differ in one important respect: the free surface. Open channel flow has a free surface, whereas pipe flow does not. Classifications of flow. Open channel flow can be classified and described in various ways based on the change in flow depth with respect to time and space. The fundamental types of flow dealt with in open channel hydraulics are: time is the criterion. Steady flow, the depth of flow does not change over time, or if it can be assumed to be constant during the time interval under consideration. Unsteady flow, the depth of flow does change with time. Space is the criterion. Uniform flow, the depth of flow is the same at every section of the channel. Uniform flow can be steady or unsteady, depending on whether or not the depth changes with time. Varied flow, the depth of flow changes along the length of the channel. Varied flow technically may be either steady or unsteady. Varied flow can be further classified as either rapidly or gradually varied. Rapidly varied flow, the depth changes abruptly over a comparatively short distance. Rapidly varied flow is known as local phenomenon. Examples are the hydraulic jump and the hydraulic drop. Gradually varied flow, the depth changes over a long distance. Continuous flow, the discharge is constant throughout the reach of the channel under consideration. This is often the case with steady flow. This flow is considered continuous and therefore can be described using the continuity equation for continuous steady flow. Spatially varied or discontinuous flow, the discharge of a steady flow is non-uniform along a channel. This happens when water enters or leaves the channel along the course of flow. An example of flow entering a channel would be a roadside gutter. An example of flow leaving a channel would be an irrigation channel. This flow can be described using the continuity equation for continuous. Unsteady flow requires the consideration of the time effect and includes a time element as a variable. Summary of the classification of open channel flow: steady flow, uniform flow, varied flow, gradually varied flow, rapidly varied flow, unsteady flow, unsteady, uniform flow, unsteady flow, gradually varied, unsteady flow, rapidly varied, unsteady flow. States of flow. The behavior of open channel flow is governed by the effects of viscosity and gravity relative to the inertial forces of the flow. Surface tension has a minor contribution, but does not play a significant enough role in most circumstances to be a governing factor. Depending on the effect of viscosity relative to inertia, as represented by the Reynolds number, the flow can be either laminar, turbulent, or transitional.